Hello class, welcome to Algebra Lesson 1-7, which is all about solving absolute value equations. By the end of this lesson, you should be able to write and solve absolute value equations. So let's jump into example 1, where we will practice understanding what an absolute value equation is. So let's quickly just remember what absolute value is. Absolute value is drawn using those straight lines, okay? And absolute value measures the distance a number is from 0. So like if I had the absolute value of, let's go with 14, how far away is 14 from 0? The absolute value of 14, the distance from 0 is 14. If I have the absolute value of negative 14, how far away from 0 is negative 14? Some of you might say 14, and some of you might say negative 14. However, whenever we're talking about distance, remember, distance is always going to be a positive number. You can't have negative distance. If you have a negative number associated with distance, usually that just tells you what direction you're moving in rather than how far something is, okay? So absolute value of a positive 14 is 14. The absolute value of negative 14 is also 14, because all absolute value does is measure the distance from 0. Okay, so now that we've refreshed our memories on what absolute value is, let's look at what is the value of x in 9 equals the absolute value of x plus 6. So as you can see, I have not just one solution, I have two. So I'm going to be able to write two different solutions to this equation. So if I have 9 equals the absolute value of x plus 6, my first step in solving any absolute value equation is you always want to get absolute value by itself. So my first thing I'm going to do is I'm going to say minus 6 and minus 6, because that way I'm left with 3 equals the absolute value of x. Now that I have the absolute value of x equals a number, I know that I have two possible answers that can fill in here. What two numbers are 3 units away from 0? Well, the absolute value of 3 would be one answer. So I'm going to plot a point at 3. And then if I think about it, what other number would be 3 units away from 0? Another number that would be 3 units away from 0 would in fact be that negative 3. So I'm going to plot a point at negative 3. And it is okay to plot these on the same number line. So if you would prefer to do them on the same number line, that's totally fine. I just happen to have two number lines on this slide for some reason, so I thought I'd use both. But my answers, x can equal 3 or negative 3. Okay, so absolute value equations, you should always have two answers. All right, now let's talk about what is the value of x in 17 equals the absolute value of x plus 5. And by let's talk about this, I mean, why don't you try it first, and then when you're done with it, I will walk through it and see if you got the right answer. Good luck. All right, hopefully for this problem, you subtracted that 5 first, and then you just had the absolute value of x equals 12. And we know that the absolute value of x equaling 12 means that we have to have two numbers, positive 12 and negative 12, as answers. Okay, example 2. Let's look at a slightly more complex absolute value equation. So let's say we have the absolute value of 3x minus 6 equals 3. So in the last couple problems, I explained you always have two answers. So when you get to slightly more complex, you have a number with your variable, you have a coefficient with your variable, you're going to split into something called case 1, meaning your first answer, and case 2, meaning your second answer. Okay, so you're going to be splitting into case 1, case 2. Case 1, you just copy whatever's in your absolute value and basically just copy the problem the same way. Case 2, you copy everything from inside your absolute value, but instead of equaling a positive 3, I'm going to set it equal to a negative 3. Okay, so I have case 1 and case 2 all set up. Now I just solve them like normal equations. I'm going to add 6 to both sides. So then I'm left with 3x equals 9, divide both sides by 3. I have x equals 3 as one answer. And then some of you might be tempted to say, well, our answer is going to be 3 and negative 3, and just move on and rush, and you're going to get half the problem wrong, because let's see what happens. If we add 6 to both sides, I now have 3x equals 3. So x doesn't equal negative 3, x equals 1. So if you're someone that rushes through this and you're like, ooh, I see a pattern, you just write down the positive and negative version of the same number and you are good to go. That is a lie. Don't fall into that trap, okay? The only time that works is when you just have the absolute value of x and there's nothing else in the problem or nothing else in the absolute value with it. Okay, so let's actually quickly check to see why this works. So if I do the absolute value of 3 times 3 minus 6, and then we want to see, does that equal 3? Well, 3 times 3 is 9. So then I have the absolute value of 9 minus 6, which is the absolute value of 3. And is the absolute value of 3 3? Yes, so I know that answer works. Now, I'm going to do the absolute value of 3 times 1 minus 6 and see, does that also equal 3? You might be tempted when you are checking your answer to set that equation equal to a negative 3 because that's what case 2 is. However, we aren't checking to see if it works for this part. We're checking to see, does this work for the original equation? Okay, so then 3 times 1 is just 3 minus 6. So I have the absolute value of 3 minus 6. And then 3 minus 6 is a negative 3. The absolute value of a negative 3, is that 3? Yes, so I know that my answers are correct. So that means my answers are x equals 1 and 3. Okay, so that is how you solve a slightly more complex absolute value equation. Why don't you go ahead and solve this one on your own? Good luck. All right, hopefully for this problem you ended up with x equals 1 or x equals negative 4. You can see my work over there on the left-hand side of the screen, and you can also see how I checked my answer down below. If you have questions about that, please don't hesitate to reach out and ask for some help. Let's move on to example 3, understand absolute value equations. So we are still just doing the same thing. I'm just mixing it up a little bit. So on the very first slide, we just had x inside our absolute value, right? So then since we just had x inside our absolute value, we just had to move that random number, that plus or minus whatever, over to the other side of the equal sign. So you had absolute value of x equal the number. Then in the last slide, I gave you the absolute value of like a number times x plus or minus a number equals something, okay? And we talked about how you have to do case 1, case 2. Now I'm giving you something slightly more complex yet. What you are going to do is, you can see we have 3 times the absolute value of x minus 4 plus 21 equals 27. So before I do case 1 and case 2, I need to get, so I just have the absolute value of x minus 4 equals a number. Before you do case 1 and case 2, you just need to isolate your absolute value. Okay, this is a really common mistake people make, and I don't want you to be that person, okay? So let's start by, first we have the absolute value of x minus 4 plus 21 equals 27. And sometimes when people are writing down their work for absolute value, they make those absolute value signs like really close to the same size as their numbers and variables, and then all of a sudden they treat this like a 41 and get all confused. So be careful with your handwriting. Don't let that be something that trips you up. So just like solving equations previously, what I'm going to do is I'm going to move that 21 over first. So I have 3 times the absolute value of x minus 4 equals, and I'm going to subtract that 21, so I'm left with 6. And then I need to get absolute value by itself, so I have 3 times the absolute value. So what I'm going to do is divide both sides by that 3. So I'm left with the absolute value of x minus 4 equals 2. Now I can do my case 1 and case 2. So I have case 1 is going to be x minus 4 equals 2. And then case 2 is going to be just x minus 4 equals a negative 2. All right, so then it's pretty straightforward to solve from here. I'm going to add 4 to both sides, so I'm left with x equals 6, and I'm left with x equals 2. And then what I can do is I can check my work. I can say 3 times the absolute value of 6 minus 4 plus 21. Does that equal 27? 6 minus 4 is 2, so I have 3 times 2 plus 21 equals 27. So that's 6 plus 21 equals 27, which is true. So I know 6 is a correct answer, and then I have 3 times the quantity, or the absolute value of 2 minus 4 plus 21. Does that equal 27? So I have 3 times the absolute value of negative 2 plus 21. And the absolute value of negative 2 is just 2, so 3 times 2 is 6 plus 21 equals 27, and I know that's true. So I know my answers are x equals 6 and x equals 2. All right. So you can see I'm doing a lot of checking of my work on these, and that's because these are problems that are really easy to get incorrect. All right, so now I want you to solve this one. I'm just going to rewrite it once to make it a little nicer looking for you. So we have negative 1/2 times the absolute value of 6x minus 3 equals a negative 3/2. Go ahead and solve that. Good luck. All right, hopefully for this problem, you ended up with x equals 1 and x equals 0. You can see that I finished isolating the absolute value in red before I went to splitting it into case 1 and case 2, which is written in green. And then I used the black, it shows my work, for checking my answers. And you can see that they work out when I do that. So let's look at our very last example for today. It is write and solve an absolute value equation that represents the situation. The average number of cucumber seeds in a package is 25. The number of seeds in the package can vary by 3. Find the range of acceptable numbers of seeds in each package. So you might read this problem and just say, oh, dude, that's easy. 3 more than 25 is 28. So that's the most, and 3 less would be 22. You're like, boom, done. Except you forgot about this part of the question. Write an absolute value equation. But the good news is if you can figure out that the numbers are 22 and 28, you can work backwards and check your work to make sure that your equation works. So if I know that the average number of cucumber seeds in a package is 25, and the number of seeds can vary by 3. So what you're going to do is, in this equation, whatever number something can vary by, that's the number that's on its own. Okay, that's the equals blah, blah, blah. And then the absolute value is going to involve your other numbers. It's going to have your variable and the other number you have. So the average number of cucumber seeds in a package is 25. So I can do 25 minus x, right? Minus whatever number that would be. Like I said, this problem's pretty straightforward. So you might have just been able to look at the problem and figure out that the numbers are 22 and 28. But now that I have this equation, I can test it to see, does this actually work? Or maybe you were someone that was thinking, I think you would do x minus 25 because we normally put our variable first. So let's try that. This is what most people tend to just do naturally on their own. So if I do that, then I'm going to split it in case 1 and case 2, right? So then I'd have x minus 25 equals 3, and I would have x minus 25 equals negative 3. So then if I move this 25 over, I would have x equals 28. And then if I move this over, I have x equals 22. Sweet, that works, right? Okay, let's try this other one. So if I have 25 minus x. So case 1, 25 minus x equals 3. Case 2, 25 minus x equals negative 3. So if I move that 25 over, I have negative x equals negative 22. Divide both sides by that negative, you get x equals 22. Then if I do this one, subtract 25 from both sides, I have negative x equals negative 28, or x equals 28. So you can see that in this instance, it didn't matter what the order was. Both of those answers would be correct. And that's one of the cool things about the absolute value. However, if you get problems that are more complex, where you maybe have like 3x minus 28 equals 14. I don't know, I just totally made that up, okay? That's not going to work out as nicely as this instance, right? This one works out nicely because x is all by itself. It doesn't have a coefficient with it. So yes, this problem is straightforward and works out nicely in multiple ways, but not all of them do. So you always want to make sure you're checking your work as you go. So whenever you have to write an equation, test it. Don't just assume that you got it right, okay? And when you test it, because I see this happen a lot, when you test it, don't just write down the answer that you think is right. Sometimes people just assume their equation is going to work, so they don't actually take the time to stop and think about what they're doing. Don't let that be you. All right, question 4, apply absolute value equations. Members of the track team can run 400 meters in an average time of 58.2 seconds. The fastest and slowest times can vary from the average by 6.4 seconds. Find the range of times for the track team. Good luck! Okay, for this problem, hopefully you said that the range is anywhere from 51.8 seconds through 64.6 seconds. You can see that there are multiple ways to set this equation up as well. So you could either do the absolute value of x minus 58.2 equals 6.4, or you could flip it and say the absolute value of 58.2 minus x equals 6.4. And if you were to solve that second one, you would get the same thing. Okay, so hopefully that gives you a good foundation to work from. If you have questions, please don't hesitate to ask. I know absolute value equations can seem rather overwhelming at first, and that's normal, okay? Just be sure that you don't let yourself sit there stuck and confused. Make sure you ask questions, okay? Okay, I realized after I ended the video, there actually is one more thing I need to teach you about absolute value equations. So that is how you can end up with a no solution for an absolute value equation. So on the very first example, I talked about how the absolute value of anything is always going to be positive because the absolute value means that it's the distance from 0. So if we look at this first example right over here, that absolute value of 4m minus 1 equals a negative 2. This number, right, because the 4m minus 1 just represents a single number. Like once we figure out what m is, that represents a single number. And so the absolute value of any number is going to be positive. So even if it equals a 2, the absolute value of 2 or negative 2 will never equal a negative 2. So if you ever have the absolute value of something equals a negative, this is called a no solution. All right, and then let's look over on the right. You can see that I have an absolute value equation. Again, it equals a negative number. However, you cannot jump to this no solution stage until you have it the absolute value isolated. So the first thing I need to do is move that 2. So I have negative 7 times the absolute value of x plus 1. And then I move that 2 by adding it, and I'm still at a negative 4. But I have this negative 7 over here that I need to move as well. So then I have the absolute value of x plus 1 equals a negative 4 divided by a negative 7 becomes a positive 4/7. So even though the original thing says it's equal to a negative number, you cannot say no solution until you have absolute value equals a negative number. And since this 4/7 became positive, this problem can be solved. It's not considered a no solution. Okay, so if you have absolute value, everything inside absolute value equals a negative number, no solution. If you have the absolute value of something equals a positive number, you're going to get a solution. So hopefully that makes sense. If not, please don't hesitate to ask. I am more than happy to help you. Have a great day.